that comes up, that kind of pops into my head, and let me know if you have any other questions, okay? So basically, the word parabola refers to the shape of the graph of a particular type of function, okay? So you'll learn about functions in about algebra or so, maybe pre-algebra, and you definitely go into it a lot more in pre-calculus, okay? If you want to go into the basics of functions a little bit more, I highly recommend that you check out my Basics to Functions video. I think it's in the pre-algebra playlist, but in general, I will be filling in topics at different levels and hopefully filling in the playlists. So that will be the basics, like the very, very basics of functions. But the functions that generate this parabola are quadratic functions. Quadratic functions. Okay. And all that means is, I think so far we've mostly talked about linear functions, and even then I didn't even explain why they were called linear. And that is because we haven't set up the xy coordinate plane yet, the Cartesian coordinate plane, but we will be doing that soon. We've only talked about the number line, but either case, it refers to the graph of these equations, and I kind of touched on it with functions, but basically, let's say we have a function that says this: y equals x squared, where y is a variable, x is a variable, and y is a function of x, so we can write that as f of x. So basically what this means is I give you an input x, I choose whatever it is. It can be 5, it can be 10, right? It could be negative, it can be star, okay, who cares? What this tells me is that my y value is that input squared. So it's like a set of instructions for what to do with my input to get a corresponding output, okay? So in order to graph this, which you probably have already learned, if you've already learned lines and stuff by the time you learn about parabolas, you've probably worked with linear equations already. But what you do is you can pair up your inputs and outputs to find some points on your graph. So I'm not going to do it precisely today, just because I don't have like my graph paper. I will do that at some point soon. But let's say I pick an x value. So let's say I do -3. So this tells me that my y is going to be -3 squared, which is +9. Okay? Let me know if you want to review squaring numbers and working with negative numbers, but I'm assuming if you're learning this stuff that this is okay for you. But don't be shy, okay? If anything here confuses you, let me know. But basically, I am going to pick a bunch of x values, and I'm just picking them so that they're kind of convenient to graph. But otherwise, there's no reason to not pick, there's no reason to not pick something else, whatever, like 100. Then you square 100 squared. And all I'm going to do is square each of those values. So 0 squared is 0. 1 squared is 1. 2 squared is 4, etc., etc. Okay? So the idea of graphing is just that I can pair my inputs and outputs together to form an ordered pair. And it's called an ordered pair because there's an order. The first number is always going to be x, and the second number is always going to be y. So let's see here. Okay, so here, this corresponds to, sorry about that, this is in the way, but it corresponds to -3, 9, like that. Okay, this is -2, 4. this is negative 1 comma 1. So basically I'm pairing all the inputs and outputs, the outputs that correspond to the inputs, and putting them like this, parentheses, input comma output. So you can see that we have pairs of numbers. These numbers are paired together and they're ordered because the first number is always x and the second one is always y. It's the independent variable, comma, the dependent variable. Okay? So basically, these ordered pairs each correspond to one point on the graph. And so since we haven't really talked about the Cartesian coordinate plane yet, I'm going to kind of do this I'm just going to sketch it out because I don't want to take time to do this too precisely without having actually talked about it here. But we've done the number line, so you'll recognize this horizontal line with the tick marks, right? And then you need to label. You need to set your 0 here at the center, and then you need to label your units, right? So this is a number line, and actually you're basically going to also have another number line that's up and down like this. And keeping track of two number lines makes the coordinate plane. And so if you plot each of these points, okay, so let's say 0, 0, I'm just going to plot a few here really quickly. Negative 1, 1, 1, 1, 2, 4. So again, if this is kind of too fast and I'm losing you, don't worry about this part. I'll come back and do this part slower. But my point is that if you sketch this out, it will look something like this. Okay, this is a parabola, so this sort of U-shaped thing that kind of comes to a point. Okay, can't even quite describe it. It looks something like that. Okay, is a parabola. That's what the parabola is referring to. And so up to this point, you've probably studied lines and will study them here. But they have this form, y equals mx plus b. So those are linear equations, and we'll get into that. But the graph of those are just lines, as you probably would guess. Sorry about any background noise. So lines, but this is a parabola. Okay, so quadratic functions look like parabolas. And so what are quadratic functions? Well, lines have this form, and we'll study this. This has like a y-intercept. This is the slope, etc., etc., right? We'll go into that. And I said that this is your most basic parabola. The reason I say that is because this, you'll notice that this point right here at the very bottom, it's called the vertex, is at 0, 0. It's at the origin of this coordinate plane. And there's no number in front, it's just y equals x squared. So the coefficient of the x squared is 1. So this just has like standard width, I guess you could call it that. And the vertex is at the origin. But quadratic functions in general, and this will be important to note if you're studying parabolas, quadratic functions in general and parabolas in general. Okay, so one form of a quadratic function is ax squared plus bx plus c. Okay, so y equals ax squared, and basically, so you'll notice that this is just y equals mx plus b for linear equations. For quadratics, you will have this exponent of 2. Okay, that will be the highest degree, as it's called, but it is the exponent of x terms, the variable, right? So in this case, x, so x squared. So 2 will be the highest one, and it will look like this. You'll have some sort of coefficient, so a, b, and c are numbers. y is my function of x. And so you'll have something times x squared plus something times an x plus some other constant number. So this is the general equation for a quadratic function, and therefore the graph of these functions will look like parabolas. Okay, so the b and c, I told you a, b, and c are numbers, but b and c can be 0. Okay, like in this case, but a cannot equal 0, because if a equals 0, you'll get 0x squared, which becomes 0, so you'll end up just getting bx plus c, which is linear. So as long as you have at least an x squared somewhere in there, okay, and even if these two are 0, it's still quadratic, as we see. So you'll see here, for instance, a is 1. You can actually picture this as 1x squared plus 0x plus 0, right? If you want to strictly write it as something x squared plus something x plus something, it's just 1, 0, and 0. So these go away, and that's why you get this. But this is still a quadratic function, okay? So as long as we have a, b, and c here, or we can define it in this way, we have a quadratic function, which means the graph will be a parabola. So just to own in that point, basically you could get like 5x squared minus 2. Okay, this is still a quadratic function. Y equals 5x squared minus 2, because the coefficient of the x squared term is 5. The number that goes right before the x squared is 5. There is no something x, so that's basically plus 0x. So b equals 0 and c equals minus 2, because a plus minus 2 is minus 2. Okay, so we have a, b, and c, and so this is still a quadratic function, and the graph of this will be a parabola. Okay, so first thing is to be very clear with what quadratic functions are. So then the next thing is, when we study parabolas specifically, we are going to study properties of the parabolas. So for instance, questions to ask would be, is this parabola, the graph of the parabola, is it facing up or is it facing down? So is it a happy face like this? Okay, or is my parabola actually facing down like this? Okay, and we can also ask stuff like, how wide is the parabola? So is it like this, or is it super thin like that? But it shouldn't be straight, it should be still curved, but it could be really quick, so to speak. Okay, so we can study stuff like that. And the way to do that is to look at the standard form of a parabola. We can also ask questions like, where, notice that all these parabolas have some kind of peak point, right? Either at a minimum or a maximum, right? So the lowest point will be here, or here if it's upside down, that point's gonna be a maximum, and that point is called the vertex. Vertex. And you'll see that it's symmetric. It should be symmetric. We'll have to take a look at the equations a little bit more to really show that. But if you draw a line, vertical line down from the vertex, your parabola should be symmetric. This one doesn't quite look like it, but that's my bad. They should be symmetric. Okay, so to answer this kind of question, like, where's the vertex? Is it facing up or down? How quickly is it? Like, what's the rate? How quickly or slowly is it growing? Kind of like the equivalent of the idea of slope for lines. You can ask something like that, roughly, with parabolas. And so the way we're going to do that is we're going to look at the standard form equation in general, y equals ax squared plus bx plus c. But we can actually rearrange something that looks like this into the standard form. That's what it's called, the standard form. Here, I'll just write this on a new one. The standard form of a parabola. And that's going to look like a times x minus h squared plus k. Okay, so this is y equals this. So here we go again. We have letters all over the place, but remember, x is our variable in this case, right? Y is a function of x. A, h, and k are numbers, okay? So if we already have a quadratic that looks like this, we will know that the vertex is at h comma k. So we're just going to find those numbers, and the a will tell me if the parabola is up or down. If a is greater than 0, it will face up, and if a is less than 0, it will face down, like that. Okay? So, like I said, we can definitely graph, like we can work with specific examples of this, but if you are studying parabolas, I would be willing to bet that you have seen this form, because this is so important, and this, just reading off of this form, we can get the vertex, meaning when we graphed our original, most basic parabola, we have it centered at 0, 0, but we might have parabolas like out here, okay, or upside down like this, right? So to be able to sort of get these properties, we have to write it in this standard form. Okay, so I hope that kind of helps. I think I am running out of time right now, but I will work out a specific problem, so keep an eye out for that. Like, I guess it'll be a part 2 to this, but I will write out a particular parabola in just your basic general form like this, and what you'll need to do is factor out this number, this a of this part, and complete the square so that you get something that looks like this, and you can always do that algebraically. So you go from this form to this, and from this you can read your h comma k as your vertex, okay? And then you should be able to graph it from there. Okay, so anyways, I hope that this kind of gives you a very, very, very rough idea. We will definitely come back to graphing on the xy coordinate plane when we get to setting up the Cartesian coordinate, how it actually works, and working with ordered pairs and stuff, and we'll actually probably start with graphing lines. But let me know if you have any specific questions. I really go by comments, so let me know. And let me know if there's anything more about parabolas that I can help you with. One more thing that just kind of popped into my head is notice that you won't have a parabola that looks sideways if it's a function, because that would not satisfy the vertical line test. And just the definition of functions in general, remember that for each x or each input you need to have a clear y value, so you can't have two. So that's why. So your parabolas will only ever look this way or this way. And yeah, so that's what we're studying. Okay, so from there we can study just properties of this, and I hope that kind of helps. This is actually, if you are studying this not in algebra, usually you're introduced to the idea of parabolas in algebra, but if you're studying this in pre-calculus, you'll see that this is part of the conic sections. So yeah, there you go. Okay, anyways, I hope that this was helpful. Let me know if you have questions. Thanks so much for joining me. Subscribe if you want to see more math topics. I'm just kind of jumping all over the place and at all different levels. So either way, I hope that you find these videos relaxing